This is Algebra 2, Lesson 1.3, Shifted Geometric Sequences. A shifted geometric sequence, just like the sequences we've been dealing with, are lists of numbers. And in this case, that list of numbers will use both multiplication and addition to generate its terms. And now it can be addition and subtraction, because remember, adding a negative is the same as subtracting, okay? The recursive formula is going to start the same way we've been doing it. U sub n equals U sub n minus 1. Then we will multiply by our common ratio, and we will add our common difference. We also have something called the long run value. I'm going to use LRV for that. And to calculate the long run value, you would take the common difference, divide it by 1 minus the ratio. Properly, we can stack this fraction vertically, but I like writing it to the side with parentheses because that kind of better represents how you should be typing it in the calculator. So those are our formulas. Let's try a couple of examples. Example A says, suppose a doctor prescribes 16 milliliters of medicine each day, but your kidneys filter 25% of the medicine from your blood each day. Write a recursive formula that gives the amount of medicine in the blood. So we need to calculate our ratio, and to do that, we're going to think about our percent decrease formula from the previous lesson. To calculate our ratio, we start with 100% of the medicine in our blood, and then the kidneys are filtering or removing 25%. 100% take away 25% is 75%, and I know to represent my percent as a decimal, 75% would be 0.75. A recursive rule always starts with a starting value then. So let's see, should we say U1 or U0? Let's say U1 because we start with 16. Yikes, yikes, yikes. Which way did he go? There he is. We'll say U1 is 16 because we have 16 on the first day. And then to get the next value, we need to take the 1 before it, and we will be multiplying, that's our ratio, by 0.75, but also taking another dose, so also adding another 16. So each day, 75% of the medication remains when 25% is filtered out, but we take another 16 milliliter dose to replace what our kidneys filter. How much is in your blood after 5 days? So I'm going to go to my calculator for this. We do have our formula right here. I know to start with 16 on day 1. And then I'm going to times by 0.75, but also at the same time plus 16. And now I want to get to answer 5. So that's day 1, day 2, day 3, day 4, and day 5. With this calculator, I can put both operations in at once and just keep hitting enter. If you are using a different kind of calculator, like maybe a cell phone calculator, you might have to do times enter plus enter, times enter plus enter, and retype that. So make sure you have the right tool to make this easier for you. So I figured out that on U5, on day 5, we have about 49. I'm going to just round to the nearest whole number. On U5, we have about 49 milliliters. How long will it take for the medication in your blood to reach 60? Since I already have this keyed into the calculator, I'm going to keep hitting enter and count as I go. I'm going to count how many more enters it takes to reach 60. So on day 5, I have 48. Here's day 6, day 7, day 8, day 9, Day 10, day 10. It takes me 10 days to reach 60 milliliters. Let's see if I want to round that differently. Nope, I'm going to keep 60. So day 10 would be my answer here. And the next question, how much medicine will remain in your body if you continue to take it regularly? That means find the long run value. So if we keep taking this medicine and keep taking this medicine and keep taking this medicine, hopefully you notice it actually changes less and less and less every single time, right? There was a pretty big jump initially, but then we were like 55, 57, 59. So it took a long time to grow at the end. So if we keep going, what we're going to notice happening is the values really don't change very much at all. And I can kind of tell right now that my long run value is going to be probably 64, but we're going to use the formula that I gave above to figure that out. To get our long run value, we need our common difference, which in this case was 16, divided by 1 minus our ratio, which in this case was 0.75. I'm writing that with parentheses because if you just type 1 divided by, it's not going to give you the right answer. We need to do the denominator first, but if I add parentheses, I can do it all in one big step. So I'm really doing 16 divided by 0.25, and that is, as we already saw, 64. So if you take your medicine every single day, you'll keep a constant 64 milliliters in your bloodstream. Next example says, Antonia and Deanna are working at the community pool for the summer. They need to provide a shock treatment of 450 grams of dry chlorine to prevent the growth of algae in the pool. Then they add 45 grams of chlorine each day after the initial treatment. Each day, the sun burns off 15% of the chlorine. Write a recursive formula that models the situation. So again, we need to figure out our ratio. And if we are burning off or removing 15%, to calculate that ratio, I would start with 100%, take away 15%. That gives me 85%, and 85% as a decimal is 0.85. So my formula, let's say on day 1, let's say day 0. On day 0, come on, they put in 450 grams, and then the sun burns off 15%, so only 85% remains. So they need to add 45 grams a day to maintain the chlorine levels in the pool. So how much chlorine is there after 1 day, after 2 days, after 3 days? We're going to go to the calculator. We are going to start with our initial value today. Today we add 450. Then we're going to burn off 15%, but replace it with 45 grams. So after 1 day, we have 427.5 grams in the pool, after 2 days, and after 3 days. So I'm going to write each of these. U1 equals, I'm not going to remember these. This is going to be back and forth. U1, 427.5. U2, 408.4. Let's round that. 408.4. And U3, 392.1. Find the long run value. So if you really want to get some aggression out, you could just keep hitting enter a bunch until we see the values start to level off. But I'm going to go ahead and jump to that formula to get the long run value. First, we need the common difference, and the common difference in this case was 45. Divided by 1 minus the ratio. Ratio in this case was 0.85. So we could do 1 minus 0.85 first to get 0.15, and then we would do 45 divided by 0.15, or I can type the whole thing into my calculator because my calculator is really good at order of operations. And that tells me that I would level off at 300. And you can see that decreasing value, right? We started at 450, 420, 408, 392. It's decreasing, decreasing, decreasing. Once it reaches 300, that's going to be the maintenance level. It's going to stay at 300 as long as they keep adding 45 grams every single day. Okay, those are our notes for this lesson. Good luck on the exercises, and please let me know if you have questions.